All right. Hi, everyone. Hello to all of our friends around the globe. I am Kim Garriott, and I am the General Manager of Global Healthcare and Life Sciences at NetApp. And I will serve as today's moderator as well as a co-presenter for today's content for this month's SIIM partner webinar. And the topic that we will be exploring is navigating medical imaging data storage management with AWS. Oh, I have to get used to that. Sorry about that. So, as I mentioned, I will be one of the co-presenters, and I'm joined with my good friend Sasha Pagel, who is a business development manager for healthcare and life sciences at Amazon Web Services. Just
Hi, everybody.
just a reminder of some credit eligibility. I think most of you are aware of this. And be sure to ask questions throughout the presentation using the Q&A function found in the Zoom menu. And we will host a Q&A session at the conclusion of the presentation. But if I see a really juicy question that's really relevant, I may just pop it in real time and put Sasha and I through the ropes. So today's session goals, right? I want you to become familiar with cloud for medical imaging workflows and understand the factors that influence cloud storage choices, as well as being able to develop an awareness of cloud storage implementation patterns for medical imaging. And that by the end of this session, you're going to feel empowered and see a pathway to success with cloud storage as an option for your medical imaging workflows. So just a quick overview of the agenda. We will be going through some considerations for managing images in the cloud, current state PACS and VNA deployment models, and then storage types that can be associated with those current and future. Cloud implementation, what that looks like and what that takes, and big considerations around that. And then cloud storage choices, and then of course time for Q&A at the end. So without further ado, we'll get started here. So why consider cloud storage for medical imaging? And Sasha and I make a really deliberate effort in our partnership to always be connecting with our imaging software vendors, our PACS and VNA software vendors, with customers, and of course, with all types of stakeholders across any environment to really understand what are your challenges in managing medical imaging data. And we then play that in and inform the solutions that we develop and bring to market together with AWS and NetApp. So some of the key top considerations that we hear consistently are that, we know that the top 10 imaging ISVs or independent software vendors are bringing one or more cloud solutions to the market for you. Cloud providers such as AWS are introducing services that align with imaging solution requirements. So a whole new breed of capabilities out there to complement your PACS and VNA. And then we also are seeing really good success with early adopters with imaging solutions in the cloud. We also know that there are a host of data management and protection challenges that are, really strong in the industry today. And when we look at those, we see that, increasing image size and increasing study volume size. And this is really true when we start thinking about, breast tomo, or we start thinking about digital pathology and the impact that that's going to have on how we manage this medical imaging data. We know that cyber attacks are on the rise, and it's a very high cost to recover. In fact, healthcare ranks second in the highest cost for ransomware recovery. And then we also know that downtime is very costly in healthcare. It's costly when it comes to lives, and it's, secondarily costly when it comes to the financial component of that, which on average is about $80,000 an hour in a medium-sized hospital. And then also another contributing factor is AI and ML and being able to use these rich data sets to be able to drive efficiency and quality into our imaging review workflows. We're seeing, 30% gains in some turnaround time with assisted AI, 20% increase in early detection and screening aided by AI algorithms. And we know that imaging, and especially radiology, is by far a focus of ML and AI development. As just recently at the beginning of October, the FDA released a new authorized device list, and there's more than 690 approved devices, and that's across the last 4 years. And 155 of those have been approved in the last year, with 77%, or the vast majority, being focused on radiology imaging. And that is only going to continue to grow. And cloud is an important component for AI and ML model training, where you need very fast compute, you need very high performance storage, and many organizations cannot afford to buy dedicated resources to have sitting in on-premise data centers. So we're seeing a big movement there. And then as we start to get into the crux of our presentation today, just reminding folks, you're very well aware of this as you live it every day, but what a traditional on-premise or on-site PACS and VNA deployment model looks like. Obviously, there are all different flavors, but in the basics, we have a number of source systems feeding into the PACS, which is made up of applications, databases, and storage, and then also the syncing to the vendor neutral archive, if your organization has one of those, with some similar components built into that. And oftentimes this environment is replicated at least once, if not 3 times, if your organization is keeping a golden or air gap copy of this information. And you may have multiple test systems that have been replicated as well. So many copies of this data can be found in organizations depending on your site and how you leverage imaging. So as we talk to organization, more discrete comments that we're hearing, right, really kind of resounds through in major themes for us around infrastructure, around performance, and around cost and that experience in the cloud. Oftentimes organizations see cloud as, this very different thing, which it is, and there's a learning curve associated with that because it is very different. There's concerns about cloud storage costs and how to properly architect the cloud storage and that cloud environment overall to have the most efficient, highly performant system while also maintaining costs. And then reducing that overall size of the data center, getting away from racks and racks of compute and storage to reduce that real estate footprint, to reduce that carbon footprint, and also be able to allocate valuable resources to more high value projects within your organization. So ensuring accessibility, increasing efficiency, and reducing costs are these really high level themes that we're hearing from customers and software vendors as to why this movement of the cloud is happening now. And so Sasha is now going to take us through some more basic technical components of medical imaging, and then we'll tie it all together into this cloud journey. Oh, you're on mute, Sasha. Oh, Sasha, can you hear me? You're on mute. Okay.
All right. I think we're good now.
Yes,
very good. All right. So Kim, thanks for that introduction. So I thought as a way to start, and then I realized that there are many of you from a variety of different backgrounds, it would be great to just take a pause and just sort of a quick review of the different types of stores that images flow across. One, mental model that you can kind of think of is hot, warm, and cold storage. That hot storage tends to typically be something that's called block storage, where data is stored as an individual block and has a unique identifier or an address. And oftentimes you see it associated supporting databases. Sometimes it may, depending upon your solution or application, may be used for ingest for hot images. And typically may be the highest cost in terms of storage. The next sort of area of storage is file, and sometimes it's referred to as network attached storage. And a lot of times it's used to facilitate being a nearline archive, especially with vendor neutral archives. But one of the things I want to call out is that, file can be a peculiar technology in the sense that, one, it can, today, in terms of choices, can actually be able to service workloads or use cases that fall into, let's say, that hot category or block category. And at the same time, depending upon your choices, can fall into be able to service the cold or cold archive category or tier of storage. Typically see file used quite a bit in the on-premise world, but more and more you're beginning to see customers, healthcare providers adopt object storage, and object is a key technology that's used in the cloud. And the management of that data is a little bit different from file and block. One of the lenses that storage is evaluated through is oftentimes through the hardware itself. You see that I've highlighted, like, you may have to consider, is it flash media? Is it SSD media? Is it hard disk media? Because that influences the performance of the particular application or use case. And there's always, these metrics like IOPS and throughput and sort of the data protection patterns that you might need to put in place to ensure that your data is safe and accessible. So the point here is that each one of these choices that you may be familiar with that are using today on-prem, they're also available in the cloud. Next. So when we're thinking about moving applications to the cloud, and through a lot of our different listening sessions with healthcare providers, Kim and I have really come to appreciate that not only our healthcare providers are in different states of maturity in terms of their knowledge and use of the cloud, but as Kim pointed out, we've been working with a number of healthcare imaging ISVs, and they're all in different sort of states of maturity and working on delivering and building capabilities to bring their imaging solutions into the cloud. To actually implement those solutions, one way to kind of look at it is first from, what sort of use case are you comfortable with? What's maybe the easiest way to step into the cloud? And disaster recovery is oftentimes kind of a first place to start for many organizations. If you remember that earlier architecture slide that Kim shared earlier, a lot of the hardware infrastructure is maintained in a second data center. All that infrastructure needed to, for disaster recovery could be mirrored and implemented in the cloud, relatively straightforward. As you consider adopting different applications, they may require you to think through different ways that it might be implemented. And so this is where you start to think about different hybrid architectures, meaning that you may have some amount of infrastructure and capabilities that are on-prem to deliver an imaging solution, and some set of capabilities that are in the cloud. And their roles may actually change over time. So initially, you may continue to depend on all your on-premise infrastructure as your primary source to deliver an imaging solution, and the cloud is a standby as a just in case. Over time, that may flip. It may be that you're all in the cloud, and your standby system might be on-prem, and that might be for business continuity purposes. And as you go through time, you're likely to start acquiring additional skills and familiarity and expertise with the cloud, which then allows you to consider implementing and delivering additional applications and services to your end users. And ultimately, at the end of the day, a lot of groups are thinking about, how can I take advantage of essentially as a solution as a service or software as a service in a cloud, and using a cloud native solution. And thinking about cloud native, this often implies a solution that's been built in the cloud using cloud native services to really be able to deliver new applications and capabilities quickly, efficiently, and at low cost. All right. Now, one of the key concepts that I would like everybody to appreciate is this concept of a managed service. And thinking about the maturity of applications, you may be working, or you may be even choosing to do this yourself, is like, can I host an imaging solution, a PAC solution, for example, in the cloud? You take the approach of lift and shift, which is really being able to essentially mirror what you're doing in the cloud and using infrastructure services to deliver an imaging solution. So, and in the cloud, as you mature, you can actually start to take advantage of what we consider as managed services. So when I say managed services throughout this conversation today, oftentimes it implies that a cloud provider, whether it's AWS or other options, there are capabilities that are being put into play to be able to take advantage of a file service, for example, like ONTAP, which has been long used on-prem to support imaging workflows, but deliver it in such a way that you're able to use it for its management capabilities to manage images and to deliver an imaging service or solution, but without having to think about or spend a lot of time about the hardware infrastructure. Let the cloud provider take care of the actual hardware, the maintenance of that hardware, and take that actually off the table and really be able to focus your attention on, really using a service to its fullest extent. And as time goes on, you'll also see that different cloud providers are starting to deliver purpose-built capabilities to deliver imaging solutions. And that's when you start to move into that sort of cloud native, cloud optimized option. One final point about this is, one, you could be doing this yourself and choosing to pick and choose, even a mix and match a different collection of these services to be able to deliver a capability to your end users. Or you may want to be working with your healthcare ISV imaging partner and really try to understand where are they kind of in the journey of developing, either lifting and shifting their existing solutions today into the cloud, and where are they in terms of building out and introducing cloud native capabilities to be able to deliver a solution. Next slide. All right. So we've talked about managed services, the concept of managed services. Now we kind of come back to, in terms of choices for storage. Highlighted earlier that you do have choices for block, object, and file. And there's even, in the case of AWS, we're also developing purpose-built storage services for medical imaging. Now, each one of these areas, and whether you look, whatever cloud provider that you're choosing to work with, in each of these categories, there's a variety of choices. May seem overwhelming, but what we'll go through today will be able to hopefully provide you with a rubric to evaluate, how and when to choose some of these storage services. And more than likely, depending upon your comfort level and your maturity in terms of using the cloud and expertise with storage capabilities, and the maturity of the imaging solution that you're using, it's very likely that your images are going to flow across, any number, and probably multiple storage services that you see here. A couple other key concepts related to lift and shift in cloud native. When you're evaluating a solution, sometimes we may be using phrases like rehosting, and that's really direct lift and shift of an application and mirroring what you have on-prem with cloud services. You may hear the term re-platform, where a solution may be adopting for example, a storage service, but modifying the application in the sense that it's taking advantage of some native cloud capabilities. And then finally, re-architecting or cloud native is really pointing to an application that's been designed in the cloud and for the cloud. One of the key highlights that I wanted to point out here, coming back to file storage, as I pointed out earlier, file is peculiar in the sense that it can service a variety of different use cases. And in our partnership with NetApp, we've been able to take the ONTAP file system and we're able to deliver it as a managed service on AWS so that it can support use cases or implementations to rehost applications or re-platform applications, and in some cases even re-architect applications. And as we go along, we'll come back to the purpose-built managed service health imaging, and we'll have a few comments at the end about that particular service. All right, lots of choices. And when I first started at AWS, usually the first question I hear is, how much does it cost? How do we price out the storage? I want to acknowledge, yes, understanding the cost to store is important, but I would like for all of you to consider how to evaluate the cost through the lens, first through your actual use case and the requirements that are driven from that particular use case, versus jumping directly to what is the dollar per gigabyte per month storage cost. And the reason I want to point that out is because all the different sort of storage categories of storage services that I've just pointed out, they all have different properties and characteristics. And one may be a better fit for your particular use case. And when you've viewed that storage, when you viewed the storage through the lens of the use case and its requirements, then the cost may actually that you pay for it will start to make sense. So the key categories to think through are, one, what is the use case? What is the application? Is it a disaster recovery use case, or are you planning to have a production pack system in the cloud? Second is, thinking through, how is the data going to be accessed? Who's accessing it? How is that data protected? What mechanisms are available to you to protect that data? Kim mentioned that this concept of a third copy or a golden copy, especially for ransomware purposes. The other lens, the third sort of pillar to look at it from, is what capabilities are available to optimize the cost to store a collection of images or a study. Other key aspect is, how would you implement the storage? How would you actually migrate your images from what you're doing today on-prem and make sure that they're effectively and efficiently transferred and managed in the cloud? So what does that migration look like? And ultimately need to cast all these capabilities or these criteria to evaluate storage need to be balanced against what is your existing experience and skill with the cloud, and also relative to what sort of experience and skill do you actually possess today. Definitely heard from many healthcare organizations that it's still early on for them and they still have a lot to learn. But there are opportunities to take advantage of what you already know and to be able to move forward. So
yeah, next. And I would add to that.
Oh yeah, Kim, please go ahead.
I would add to that, when you look at everything to the right of use case and applications, right? The data protection, cost optimization, migration, implementation, and sandwich that in between the experience and skill level. What we've learned, and the audience has probably heard many stories about, like, oh, we didn't expect to get an invoice from the cloud provider for this much money. Like, this really shocked us. And one thing that we want to emphasize over and over throughout this presentation is that you need to lean on your software, but your PACS and being a software vendor, you also need to lean on your data management partner like NetApp, as well as your cloud provider, in this case, AWS, to help you understand the nuances of these areas. You want to be careful to change the way you think about what you need in the cloud. We're used to buying commodities of compute or storage in 3-year increments. When you move to the cloud, you don't want to over provision and plan for years in advance. You don't need to do that. So you want to, change the way you think about that. There are other types of data protection that you may be able to take advantage of. And these can be simple little configuration tweaks that you either make or you miss. And that can make or break your experience in the cloud from a protection cost and implementation perspective. And that experience and skill level do not feel like you have to walk this path by yourself. It's good to go out and check the marketplace out to get a feel for what things could look like or what you could do. But buying from the marketplace is like buying full retail, right? There's a lot that you don't know or a lot that you could leave on the table by not involving your local field reps from NetApp and AWS to help you along that journey. So we want to make sure we impress upon that. And, to make this a little bit more real, we thought we would go through a little simulation with you for a fictitious AHI Memorial Hospital who's recently published an RFP that includes cloud components. And we know that their existing VNA solution supports object storage. They have a need for image exchange from their pulmonary clinic, and they want that to be cloud AI based. We know that the director of informatics no longer wants to make capital purchases for traditional storage, as we're starting to see a much more stronger trend of organizations moving to OpEx or subscription models for their technology services. We know that they have deep expertise with file storage, but limited expertise with cloud, and had a recent ransomware attack, which brought down all their financial and supply chain systems. So along with data protection, business continuance is a big concern because they're located in Tornado Alley and really need to make sure that they have geographic disparity of how and where that data is being managed. So Sasha, can you help us look at AHI and help the folks at AHI really understand what the future looks like, which is the future is now in the cloud, and the kinds of concerns or questions that they need to be raising as they go through this RFP evaluation process?
Yeah, sure. So just kind of jumping through that, we're going to dive into three different examples just to be able to go through those 5 criteria that we just talked about. So let's just imagine with AHI Memorial Hospital, their particular imaging ISVs come forward and said, hey, we think we can deliver a production PACS system in the cloud. And they actually share this architecture diagram. The architecture is outlining all the different services and components to deliver that PACS solution. And one of the few ways that you can start to kind of think about this is in terms of the different criteria or different categories to evaluate, in terms of how images are stored for this particular solution. So already here, you might be wanting to just ask is is this a lift and shift or a cloud native solution? Well, you can already kind of infer from this particular diagram, it is almost a lift and shift. If you think about, or think back to the architecture diagram that Kim shared earlier, there is the storage, the file system, there is a database component to it. There's the actual application component, sort of the classic 3 tiers. And you may be thinking about, well, hey, that's interesting, but what does that actually mean? Is there an opportunity to cost optimize in the sense that, one, can I use a storage capability to service both, say, the database component and the file storage component for this PACS solution? So that'd be something I would be asking for. So a service like FSx ONTAP, it does actually lend itself to be able to support both block and file applications. Not only would this potentially be a cost optimization, but thinking about your actual experience in maturity in terms of what you already know how to use on-prem and how to support that, you may be able to apply that again here in this particular case. And it may be actually turn out to be less to manage. So there's an operational cost you that you may be able to lower. The second area to be kind of to consider, oftentimes we hear like the application needs to be highly available. One of the things in terms of cloud services, I'd highly encourage everybody to really understand how each of the different cloud options that are available to you, how they actually think about the concepts of a region. So this is a particular geography, and then within that region, how an availability zone or a collection of data centers are related to each other, and how are they actually delivering a particular set of services or service or capability. And in the case here, we've outlined sort of 3 availability zones, and you actually see 2 file systems or 2 ONTAP file systems represented. And that's conveying that this is a high availability configuration. If your use case, if we switched temporarily and thought like, hey, I just need to use, my use case is really, I wanted to have a disaster recovery use case, then if you have an understanding of how the relationships of how availability zones work, you may actually discover, working with your cloud provider, that you may be able to do a disaster recovery use case by backing up or archiving images just to a single availability zone. So highly encouraged to dive into that, because again, that then starts to make pause to think, how easy is this going to be managed? Is this a particular way to cost optimize in terms of how much storage we use? And shifting into more of that sort of cost optimization point of view, what if AHI Memorial actually didn't have a VNA? What if the PACS was to be the system of record for all images? For all different storage services, whether it's file or block or object, one of the areas that you really want to dive into is really understand the concept of tiering, and how images might be moved from, say, high performance storage, that SSD or flash type of storage, and into a more capacity tier, that sort of warm or cold tier of storage. How is that actually done? Is that actually required for a systems administrator to implement some sort of tiering or lifecycling policy? Or is that driven by the actual application itself? Or could it be a mixture? And understanding that tiering policy really will also help you appreciate, how easy or how hard it will be meant to be able to manage this solution, and also what that cost may be. So in the case of sticking with just the FSx ONTAP example, it does have that property to be able to support both sort of a performance requirements that are needed to serve out images, whether the images need to be written or read from this particular PACS solution. But it also has capabilities to lifecycle images into a capacity tier, a lower cost tier, based on some simple configurations that are native to the ONTAP storage file system. The other area you would really want to investigate is like, how would we actually implement this? How would we actually migrate all of our images into this cloud solution, using relative to our existing on-premise applications? Again, this is an area that you want to dive into, because you may be able to parlay your existing experience with your current storage technologies, because they may offer some native capabilities to make that migration simpler and easier to move those images into the cloud. Again, solutions like ONTAP offer native capabilities, for example, something like SnapMirror, to make that transition a lot easier. And finally, ultimately, I think I've highlighted this before, is what is your current experience and knowledge, and evaluate that relative to what services are available to you in the cloud. So Kim, let's move on. So very quickly, I've mentioned ONTAP quite a few times. Again, it's personally like a favorite file service of mine, really because of its really rich set of management capabilities, and also its ability to really address that spectrum from sort of, in terms of use cases, from, say, high performance requirements to even capacity and archive requirements and data protection requirements. Lots of features and functionality. Highly recommend that if you're not familiar with what's available, be able to check those things out. But
Yeah.
very versatile set of storage capabilities.
And I
Next
think one
slide.
thing
Oh, go ahead.
Sasha, is, for those of you who already have NetApp ONTAP on-prem managing your data through our intelligent data management infrastructure, you're able to make that journey to the cloud very easily in a hybrid cloud fashion and have the same experience in the cloud on FSx for NetApp ONTAP as you do on-prem today, and have one data management console for all of your storage environment and not just separate consoles for what you're doing in cloud and what you're doing on-prem. So there's a really easy on-ramp for those existing NetApp customers. And these benefits, these differentiators, you won't find with any other data management company. So this is a really beautiful solution that you can take advantage of today. So let's talk about DNA in the cloud for AHI.
Yeah, so pointed out earlier that AHI is using a VNA. Their ISV partner introduced the capability to support object storage, and this is really where oftentimes I hear a lot of discussion about what is the cost to store over the long term images, and there are a variety of choices in terms of object storage. And you really kind of need to think through really sort of two properties of object storage to help understand which object storage to choose, and because it will ultimately impact the cost to store. So if we just go to this next slide here, there are really sort of two key concepts in terms of evaluating object storage, along with actually its performance criteria. So one of the things to point out is for a long time, object storage wasn't a viable option beyond, say, disaster recovery to support imaging applications, partly because the properties of object storage were such that at the time to retrieve an image or to get a set of images or a study, what exceeded essentially the SLA of a particular imaging application. It was tens and tens of milliseconds, wasn't satisfactory. We've heard quite from both imaging ISV partners and from healthcare providers really looking for a storage capability that provides ultimately the lowest cost to store, but also provides a property to be able to retrieve images on demand when you need it. And that comes back to introducing new object storage classes. In the case of AWS, 2 years ago, we introduced something called Glacier Instant Retrieval, which some of you may be familiar with. And it really satisfied those two properties: lowest cost to store, but at the same time be able to quickly access or get a study or images. Now, coming back to these key concepts, typically the cost to store on sort of a per month on a per gigabyte will go down the longer you store it. But the key, and so when you look at the different choices, you'll see that there'll be significant differences between different object storage classes. Typically, those that are supporting use cases where images are accessed very, very frequently, the cost to store is high. But what's also important is this concept of API access retrieval API charges. Let me rephrase that. And there's usually some sort of cost to actually touch and retrieve those images. So in the case of, say, archive storage, the cost to store, the monthly cost is low, but there could be a transaction cost to actually request those images and bring them back and make it for access. And typically those are gated in such a way that they may be higher relative to a different storage class. So the key point here and the concern is how often and how frequent are you accessing those images, because they'll influence sort of the total cost to store in terms of your object storage. next. And then finally, just moving on. So, we've talked about the PACS dimension. We've talked about a VNA, and choosing object storage. And then finally, AHI is considering using a third-party service that's all cloud native. And here, organizations like AWS were developing purpose-built services for health. And so AWS Health Imaging is one of those services. And really, one of the key questions to consider is like, who is that service really for? And first and foremost, it's designed for builders. So if your organization has an appetite to build solutions or applications, this is probably an image service to consider. The intent is to be able to optimize the ingest of images and be able to serve those images out to a variety of different applications while optimizing the storage of those images using compression capabilities, keeping a single copy, being able to reuse an image for a variety of different use cases. So the key point here is to evaluate, like, who is this particular service for? Do we actually have a capability to build off of that service? Or ultimately is, do we just need to know that the imaging ISV that we're working with is building in the cloud, is using cloud native capabilities to be able to deliver a service that, provides a variety of capabilities, fast to update, fast to introduce new features and capabilities, and be able to take advantage of that new capability. Probably the one area to dive into is, just understanding how some of these purpose-built services are, how they're priced. And again, they may even have concepts coming back to object storage and file storage. They may have concepts of tiering and how the cost to use that particular purpose-built service may change in terms of active use versus archive use. And they may even have different constructs in terms of beyond just the cost per gigabyte per month to store, but maybe there's a concept related to imaging, like storing an image set for a particular duration. So let's move on. And then finally, whether it's a cloud native service or a service, an imaging solution that's delivered in the by your imaging ISV, is thinking about the different implementation patterns that might in the cloud, in the sense that, are you consuming the imaging service as a software as a service? And really, what does that mean in terms of where are you storing your images and how much control do you have over those images? In the far left-hand side, you're putting all the responsibility or working with your ISV partner to manage all the images on your behalf. But long-term, what does that actually mean to you in terms of being, maybe you want to or are interested in switching to a new solution? On the opposite to that is, would you actually host your imaging solution in your own cloud as a healthcare provider? And what does that allow you to do in terms of control of managing your images and also being able to introduce new capabilities? And another area to consider and to discuss with your ISV partner is, are there opportunities to host data where you may retain control of the data, but you just provide access to it to a particular software as a service? And maybe that may allow you additional flexibility to enable additional applications from different ISV partners. So just implementation patterns are something to consider. So just to sum up, we walked through 3 different use cases. We tried to look at stores through the lens of really 5 different criteria. One is, what is the use case? What is the application? Need to think about the maturity of that application. One thing we didn't actually talk about very much, but one area to dive into is really, what is the performance of the particular storage service? In some cases, a file service may be able to service an imaging application and provide and meet the SLA criteria much better than, say, an object storage service. So really want to work with your ISV partner to understand what that is and how do you consume that storage. We talked a little bit about availability and durability of storage. We talked about definitely cost optimizing, especially in terms of thinking about tiers. Implementation, how would you implement it? And what probably need to think about how does that impact maybe a disruption to your particular service or line of service for imaging. And then finally, what is the ease and familiarity of the cloud, and also what are your existing expertise, and can you parlay that to be able to use in the cloud today?
All right. Thank you, Sasha. We have reviewed a lot of great content. I hope it has sparked some ideas and questions in your mind. And what we will leave you with are just a few key concepts in closing to always work backwards and keep your desired outcomes top of mind. That cloud offers any type of protocol for storage and purpose-built services to best meet your imaging requirements and the requirements of your software vendors. And that you really need to look at balancing data accessibility, protection, migration, implementation, and cost implementation requirements, along with what your organization's skill and experience for the cloud is. And you have a mix, you will have a mix of storage choices that will change over time as the cloud experience, as well as imaging solutions for PACS and VNAs, continue to evolve to take care of newer technologies. So to get started, you can easily reach out to myself or to Sasha. You've got our contact information right here. There's some websites to visit, and be sure to ask your AWS or your NetApp rep for a storage briefing for medical imaging, a hands-on cloud storage workshop, or a storage assessment with recommendations. These are no charge or low charge activities that the entry barrier is very, very low to help you get started and to learn more. And Sasha and I will both be at RSNA with AWS in booth 4357, and we would love to see you at the end of November. And again, reach out to us if you would like to have a dedicated time to meet with us to talk more about your organization's needs. So we'll close with a thank you to all of you for attending today. And that gives us a good amount of time to ask a few questions. But Sasha, before we open it up, any closing remarks that you'd like to make?
I just want to say thanks for the attention and attending today and listening to us and participating. So definitely appreciate the interest in terms of what we have to offer for medical imaging. Jumping into the questions here, the first question that I see is, what tools do you have for information lifecycle management? Really great question. So need to think about this in two dimensions. If you're from the perspective of actually managing the storage, then different storage services have different lifecycle capabilities in terms of managing images across tiers of storage. So in the case of FSx ONTAP, the file system, there are native capabilities that, similar to what you do today, on-prem allows you to manage and lifecycle images from, say, the hot performance tier and into the capacity tier. In the world of object storage, there's something, and you can also implement lifecycle policies. So based on, say, time and for example, you can move objects or images from, say, the standard S3 storage class, and based on that particular time criteria, you could move it down into a Glacier or cold archive storage class. We see many customers actually moving towards capabilities in terms of, you'll hear the phrase intelligent tiering, and usually a native storage service will actually move images to the lowest cost to store based on some dimension like time, to always ensure that the images are in the most appropriate storage class and cost optimized. So for example, S3 intelligent tiering is one such service, and over 30, 60, and 90 days, objects or, for example, studies or images are transitioned down to the lowest cost to store. And the same would be true for something like health imaging. It has a concept of an active and an archive tier. The trade-off is, do you need to manage and maintain those lifecycle policies? So if you're using individual storage services. And then the other challenge is sometimes you actually don't know when a particular user is going to request a particular study or image. So that's why something like an intelligent tiering capability becomes attractive and is usually best suited for that. That said, you also need to think about what imaging application that you're relying on, because some may actually be life cycling studies and images based on other criteria other than time. Maybe there's clinical context, and that may be tightly controlled by the imaging solution itself. And they may have already planned out and have optimized how to life cycle images across different storage tiers based on how the capabilities and the context of that particular application.
Yeah, and Sasha, I would add to that that part of the cloud workshop that we talked about on the previous slide with NetApp, FSxN, and BlueXP, we have Cloud Insights, which the word Cloud Insights is a little misleading because it can look at all of your storage capabilities on-prem, whether they're NetApp or not, regardless of whether they are file, block, or object, as well as all of your cloud instances, and help you understand and get that unified data management across all of those environments. But we can also go further and leveraging tools called Datasense, which is part of FSxN as well as BlueXP, to help you understand the age of your data, to help you understand the usage patterns that your end users have when interacting with that data. Because we know from working in imaging for many, many years that, an old saying is, we're not going to change the way we store images. We're going to keep them on pretty expensive storage because we can always buy more. And storage isn't that expensive. Storage is cheap, is the words that we've heard for a very long time. But when you factor in the masses of data that are now having to be managed, especially again with digital pathology, genomic sequencing data, and other data that your organizations may be managing to, the capacity of storage that's needed is unwieldy, and it's becoming more and more unwieldy to manage that on-prem, as well as it's not cost efficient to not responsibly manage the tiering of your data. And of course, your imaging software vendor will help you with that. But if you want a broader view, there are tools that can give you those insights to have the conversations with your clinicians and show them the costs and show them that you can, really store the data more efficiently and still have really great performance and access to that data. So there's a variety of tools out there to be able to help you make some really good lifecycle management decisions. So Sasha, there's another question around scalability, right? And that, of course, is, as the Ken asks here, and his question is a fundamental part of the cloud value proposition. But he's wondering if we can talk a little bit about how customers should expect costs to scale with data size, say by any given storage technology.
Sure. So I think we can think about sorry, I thought something was popping up through the chat here. I think we can think about this in a couple of different dimensions. One is there are taking advantage of the different storage types and different storage classes that are available. I highlighted earlier, for example, FSx ONTAP, the file system, has this property of a performance tier and also a capacity tier. The way many customers use it, and also by design, is that performance tier really represents really about 80% of the total data that's stored, and in the remaining, 20% of the data that's stored, and the 80% is in the capacity tier. So one area where there's optimization introduced is that only the most active data is in that performance tier, and the capacity tier continues to grow. It's elastic, it can grow and shrink, but you're able to get the benefits of the lower cost tier for those inactive images or studies. So that's one way to kind of think about, is like, where is that data placed and coming back, and how often is that data accessed? And usually the design or the pattern that we see is that performance tier is often relatively much smaller, even though it's higher cost relative to what's stored in an archive or in a capacity tier. Hopefully that answers the question, but that's one way to think about it. And that's the same idea would apply with object storage as well.
Yeah, Sasha, we talked about in the beginning, kind of looking at that cloud maturity model, and that, one of the starting points for many organizations is looking at backup or disaster recovery, just dipping their toe, if you will, into cloud. And I know we have a really great joint customer that has made this journey over in Australia. And I think it would be, kind of nice to share a little bit about that and how quickly Ealth New South Wales was able to migrate data to the cloud overall. But looking at disaster recovery, it's a very, very easy on-ramp for organizations to start to store their backups of their imaging data or the disaster recovery copies of their imaging data. Do you want to talk a little bit more about Ealth?
Yeah, I'll just brief highlight. So if you're not familiar, Ealth New South Wales, large health system in New South Wales, Australia, they chose to migrate roughly an enterprise imaging repository, really a VNA, into AWS, and really make it their primary sort of production system. So if you imagine those 4 different implementations, kind of leapfrogging to that third category, which is the hybrid, where the primary solution is in the cloud. And one way that what Kim's driving at is like using being able to migrate quickly into the cloud and non-disruptively. One approach was to use the actual on-prem DR source images as the initial source to seed the data into the cloud, and being able to use a native capability of ONTAP, it's called Snap Mirror, and to be able to really move that entire petabyte into the cloud quickly. And that was over a period of, say, 40 days. And then being able to, stage a cutover from the actual production system on-prem, from what was on-prem, then into the cloud. One of the things that this does point to, not only being able to take advantage of some native capabilities of the file system itself, but also thinking about how to take advantage of networking. That's something that we didn't really cover today, but along with storage is really, and I think there's another question here related to networking, is really thinking through what are your options there. In the case of New South Wales, they actually use something called Direct Connect, where you have a private connection to AWS, and they establish that connection between their existing DR center and the cloud. And that way they were able to migrate those images without disrupting the line of service that was occurring, in real time. There are other options to take advantage of, but as part of the storage conversation, as part of the sort of the performance of the application, networking becomes also a very important area to investigate and understand what your options are versus, say, accessing images over the public internet, over a VPN, or through something like Direct Connect.
Well, Sasha, I think that is it for us today. This has been a great webinar. I've loved spending the time with you, Sasha. I hope this has been valuable to all of you in the audience. Please remember to take the post-webinar survey. And again, thank you very much. Don't hesitate to reach out to Sasha, myself, or your local AWS rep or your NetApp rep. And we look forward to speaking with you in the future. And we hope to see you at RSNA. Thanks so much and have a great day.